Okay, so now if I want to talk about regression, regression is really about understanding the conditional distribution of y given x. And one way to do this is to understand the conditional density of y given x. All right, because it's telling me for a given x, y is a random variable that will depend on this little x. And I can give you the density. Now, of course, this will be a very hard task. This would require estimating a density for each possible value of x, which is really difficult. So what we do is we settle for less information. All right? So here I have a full distribution for a given x. I have a complete distribution given by maybe a PDF. And I'm going to settle for less, maybe trying to understand only the expectation of this conditional distribution. Maybe trying to understand only the median of this conditional distribution. Maybe trying to understand a couple of quantiles of this conditional distribution. Okay, so rather than understanding entirely P, I'm only going to describe P partially. Okay, so for example, one way to do it is to even forget that there's an x altogether. Maybe I'm only interested in just the expectation of y. Okay, so if I care about y, maybe I can just get what the expectation of y is. And at a course perspective, this is maybe good enough. If I'm trying to decide whether I'm going to put all my money on Google Ads or all my money on Facebook, maybe I just want to understand what the expected conversion rate is for both of those platforms, hoping that the x's are going to be of the same order typically, okay? So if you just tell me, well, the average conversion rate is, 100 for Facebook and 105 for Google, that already tells me a little bit. Okay, of course, I would want to have a much finer grain information that says, well, I want to have this information for a given amount, not in average over all possible amounts. So if I want to go a little finer, what I need to understand is not just the expectation of y, but the conditional expectation of y given a certain value for little x, for capital X. Okay, so given that you actually invest little x dollars in your campaign. Okay, so the conditional expectation is usually denoted by expectation of y given capital X is equal to little x. Okay, and so that gives me a function of x, right? So for each x, for each little x, I had a conditional distribution. Now I'm just summarizing it by looking at its expectation. And so that gives me a function, right? It's a function. You give me a little x, and it gives me the conditional expectation given capital X equals little x. Okay? Now this function, by the way, how do I write this function here? So I have an integral here. What is the integral form for the conditional expectation of x given little x, of y given x is equal to little x? Yeah. Exactly, right? So it's just the expectation, and then I have a density, which is h of y given x we wrote. So this is just y h of y given little x dy. Okay? So you would, if this is confusing to any of you, just think of this is just the density of y, right? And the expectation is just the integral of y times the density. And it just so happens that when I condition on x, this density depends on x. This function that's the conditional expectation of y given little x. This function that summarizes the whole conditional distribution of y given little x into just the conditional expectation is what we call the regression function. Okay? So if I ask you what is the definition of the regression function of y onto x, it's just the conditional expectation of y given x is equal to little x. So now I just made a completely arbitrary choice to summarize this conditional distribution into its expectation. But we have other measures of summarization to summarize, right? We could use the median, for example. Right? The median, we know it's more robust to outliers, etc. So I could talk about the conditional median. Now the conditional median will depend on x. So it's a function m of x such that when I integrate between minus infinity and m of x, the conditional density of y given x, what do I get? Yeah. 1/2. Right? So here, I assume that I have a conditional density, so I don't have any issues with like head jumps and stuff like that around 1/2. But essentially, this is telling me that the probability that I'm less than this value is equal to 1/2. And of course, the probability I'm larger than this value is also equal to 1/2. So that's the definition of the median. And everything, it's all the things that you know, except that I'm just making all this distribution depend on this little x. OK. The median is just a particular example of a, what's that? Quantile. Okay, so I could talk about conditional quantiles. All right, so I could just take, for example, this Q alpha over 2 that I've been playing with. I could make it depend on x because I just have a distribution that depends on x. And this is actually called quantile regression. It's a big field in econometrics where people are not trying to understand what the conditional expectation of, given the amount spent on Facebook ads, I want to know in average how much I'm going to be making. Maybe they're conservative. Maybe they want to know how much they're guaranteed to make at least, say, 90% of the time. So here they're actually looking for the conditional 10th quantile. Maybe they're actually looking for the conditional 90th quantile. Maybe they're optimistic. They want to know, 90, with probability, except for, 90% of the cases, my really high up there, I'm going to have something that looks like, the very high optimistic value I can get is this number, the conditional quantile at, say, 90%. I could also create a band, right? Just from those quantiles, I could actually make those quantiles change with x, right? So here, for example, if I come back here, okay, I could actually, sorry, let's just show it, I'll show it later on. I have a plot right after. Or we can talk even conditional variance. So that's not super interesting, right? If you think about what is the conditional variance of my amount made, okay, maybe it's an interesting side result because maybe you're adverse to risk. It's actually telling you how much variability there's on the y-axis for those scatter plot. And so this is a good number, but you certainly don't want it standalone. You want this number coming with some location number that's telling you maybe the conditional mean and the conditional variance or the conditional standard deviation, okay? So that you have an idea of how much variability you have in this prediction.